All right, recording started. And we're reviewing questions 31 or 21 to 30 from the CST release questions. And we'll start with number 3. That was one that a lot of people missed. And if you please look in your textbook on page 106, you're going to see a very nice little graphic there that will help you in understanding this and other questions that are in this particular quiz. So what I'm going to do is go over to the Elmo and project that. This is the guy, and basically what you see here is beta particles being deflected upwards because of the positive plate on the top. Beta particles, anybody remember what they are? Negative. They're electrons. Yeah, electrons are negative, right. Okay, gamma rays come straight through. They're not affected by the polarity of the plates. And the reason for that is that gamma rays are just pure energy, like X-rays are. Okay, they're not particles per se, but just energy. And then the alpha particles are 2 protons and 2 neutrons, which is essentially a helium nucleus, but there's no electrons. Okay, so you got 2 protons, 2 neutrons, and that makes them fairly heavy. You can stop these guys with a piece of paper or a piece of cardboard like they had in the question. So these dudes, this right here is excellent, and this page also shows you the different types of radiation. It talks about those different types of radiation and how they look in these little formulas that we did last semester, which you may not remember, and you might want to go to tutorials in my website under chapter 4, and you'd find some good stuff there. Also in my web helps. But that should take care of that one for you. And looking at the next one is question number 8. That was a often missed question in all periods. And how do you know the difference between this guy called ionic and the guy called covalent? What's the difference? Ionic. How do you know ionic? It's usually with a positive and a negative. Yeah, but what kind of an element is going to make any compound a covalent compound? Or, I'm sorry, an ionic compound. And yes, metal. Yeah, we were both thinking the right thing. I said the wrong thing. So, in this case, let's look at all of these guys here. Hydrogen, that's all there is. He's a nonmetal. Chlorine, nothing but nonmetal. Nitrogen and hydrogen, nonmetals. Carbon and hydrogen, nonmetals. So all we have there is nonmetals. We can't have ionic. So we can rule that guy out pretty easily. All right? Is it polar? Well, maybe, maybe not. In this case, all of these molecules are nonpolar for reasons that I don't want to spend a long time on, but they're all nonpolar. And it can't be metallic bonding because there's no metals. So look what's left. Covalent. Yeah. So covalent was the answer on this one, letter B. Any questions here? Okay. A lot of people missed it. So. All right. Reason that salt crystals such as potassium iodide hold together so well is, you might want to write this down, metal. Yeah. Let's try that again. A metal plus nonmetal equals what kind of compound? Starts with an I? Ionic. Good. And ionic compounds which are held together by electrostatic. Oops. Electrostatic. Okay, electrostatic is what is going to happen with these guys. In this particular case, why do these guys hold together? Because neighboring anions will be attracted to the cation. Okay, cations in this case is the potassium, right up here, and the anion is the chloride. So, because the cations are strongly attracted to the neighboring anions. So there's the cat, he's attracted to the an. And the cations are, you can remember with little kitty cat with a plus on his, yeah, okay? That's the only way I can keep them separated in my mind. I still have problem with it. Okay, so electrostatic, ionic compounds, metals with nonmetals, okay, all those guys are together. Sudnik, would you please go back to your seat? And let's go on to 10. And what type of force holds the ions together? You know this one now, don't you? Has to be electrostatic. Okay? Because what kind of a compound is it and why? Metal and nonmetal, which makes it what kind of a compound? Ionic. Right. Okay. Yeah, I can go back and do number 6. Is everybody okay on 10 here? Yeah. Okay, that thing that I wrote down on, I think it was 7, gives you the same reasoning that you have here. Number 6? Yeah, okay. Which of the following correctly shows carbon and hydrogen bond to form how hydrogen and carbon bond? Okay. This doesn't show any bonding at all. It's just showing two ions, and those ions aren't gonna, they're improperly written in the first place. So this guy's really bogus. Okay, this shows a carbon with a hydrogen, but you'll never see a carbon with only one hydrogen. Okay, so carbon and hydrogen bond to form a compound. That is not a compound. It's incomplete. Okay, and this guy, they don't form ions that way. Okay, because they're covalent. And so whenever you have carbon, carbon is always going to have 4 bonds. All right, and it can be anything. It could be another carbon that's hooked on it, could be a hydrogen, could even be an oxygen. Okay, because we have oxygens hooked to carbons, and it could be chlorine, could be a halogen. All kinds of things can be hooked up on them. So carbon and hydrogen, though, you would have, like in organic chemistry, you'll have stuff like this, where you have a 3-carbon compound. We call that propane. Okay? And this guy, each of these guys has to have 4 things hooked to them. And in propane, all of those things are hydrogens. And we haven't done the organic chemistry yet, so this kind of borders on the organic chemistry, which we're going to get into next week. We'll do more on acids and bases and organic compounds after the CSTs. Okay? So that's about as far as we're going to get with this stuff.